Okay, for this second example, we're going to do pretty much what we did in the first example, except we're going to use the depression scores as our dependent variable. And hopefully what we'll see is that the uh, two classes led to overall a decrease in depression scores about being in a statistics class. And we would hope that that would be the case, right? That both of those classes would be effective in reducing depression, and maybe it's the case that one class reduces the depression more than the other class does, but we'll find out. Okay, so in order to run this analysis, we're going to go into general linear model. We're going to hit repeated measures. Okay, and again, this is pretty much mimicking what's done in Pallant in chapter 20. So I'm going to go in here and hit time. Okay, I'm going to hit time, and I'm going to define it with three levels. I'm going to click add. Okay, now at this point, what I want you to do is to pause the video. Okay, and I want you to take it from here and go define those three levels for the time variable. Make sure that you're including the right groups, and then run the analysis and try to interpret it. And when you're done doing that, unpause the video, and then I'll pick up and we'll see whether what you're able to do there actually matches with the analysis that I came up with. Okay, so I'll give it a pause for just a few seconds and then start me back up again. Okay, so now I'm going to move forward, and so I'll click define. Okay, and that gives me three levels. I've got to define now my variables. So I'm going to pass over depression for time 1, then depression for time 2, and depression for time 3. So hopefully you were able to do that. And then we're going to hit type of class group, and we're going to put that down as the between subjects factor. Okay. Now we go under options, and this is going to give us some choices here, and the most common ones that folks will choose is descriptives, estimates of effect size, and homogeneity tests. And we'll click continue. And then we're going to do plots, and we're going to put the groups in the, these are what we're going to be following in the plots. So we'll put those as separate lines. And then we're going to have time on the horizontal axis. Okay. So then we click add, and that's going to give us the plot of the time by group relationship. We'll click continue. And then the one thing that Pallant doesn't do, and I'm not expecting that you would have just done this because I didn't show it in the first video. The one thing that Pallant doesn't do is have you run post hoc tests, which I don't really understand, because if you do get a significant effect, you'd kind of like to know where that is over time. So let's just go ahead and put group into post hoc tests. And I'm going to pick Tukey's and LSD and Bonferroni as the three to run. And so basically by doing this, if I do get a significant main effect for time, which we did see in the last video, the post hoc test will allow me to find out exactly where the significant difference is. I'm not entirely sure, to be honest with you, why Pallant did not include that in chapter 20, and there's really no explanation for that. So, but you know, that's the way she did it. So we'll go ahead and continue in that. So I'm not expecting you to have done this, but probably a pretty good idea to do that in the future. So we'll hit continue. Okay, and now we're pretty much done in terms of what we need to do here. I'm just going to click on OK. Up comes our output. And really the only trick on the output is just making sure that you're interpreting the right parts of the output. So you're going to get a lot of this sort of descriptive stuff right up front. Here's our variables. There's our type of class, math skills, and confidence building. Okay, there's the means, right? And we would like to see depression going down over time, and it sure looks like when I look at the means here that those scores are going down, which is what we would hope would happen. Okay, I'm going to go down and just check on my equality of variance, homogeneity of variance. What I don't want to see here is a significant value on any of these three rows, and I don't see that, so we're in the clear on that. Then we're going to go back up and skip over some of this output here, go back up, and we're going to interpret the multivariate tests. Okay, the first thing that we're going to look at is Wilks lambda on the time by group interaction. And so we look to see if there's an interaction between time and group, and we come over to the p-value and we say, yeah, there you go, 0.024. So there is a statistically significant interaction effect between time and group on depression scores. In other words, what we're seeing is that one group is leading to a faster reduction in depression um, about statistics, having taken a statistics course, than the other group. One of those classes had a stronger effect. We're also seeing, when we look at time, a statistically significant effect for time. Okay, so this is less than 1 in 1,000 that we'd see an F ratio of 27.289. Okay, so we've got one main effect, we've got an interaction effect, and now we need to go look to see if, in fact, the main effect for the uh, course conditions, for the courses, I should say, is significant. And when I come down here by group, okay, so this is, we're asking, is there a main effect, a difference between the groups on their mean levels of depression, irrespective of the time period? Okay, it turns out the F is 1.091, significant 0.305. So it doesn't look like there's a difference between the two groups in terms of their levels of depression, but there is an interaction effect. So when we come down and look at the interaction effect, okay, it comes down here, and you can see that basically they started out fairly equal in terms of how depressed they were about taking a stats course, and then this is where I'm sure you're getting the interaction effect, is this big difference where the type of course really mattered. So the confidence folks in the confidence building course saw a big drop in their mean scores for depression, and a much smaller drop, but still a drop, for the math skills course. And then from time 2 to time 3, those lines are virtually parallel. So there doesn't look like there was a real interaction effect there. So this is where it sort of showed up. Okay. Yeah, let me see. Maybe I was going to see if I could find the post hoc test on there, but for some reason it didn't print out, and I'd have to go check. It may be that the post hoc tests don't run. Maybe that's why she didn't check them off. Maybe they don't run because it's a within subjects factor. That could be. So yeah, so there's probably the interaction effect going on right there. So at any rate, that's the bulk of the output. Hopefully you got something that looked very much like this, and that's pretty much it. So we'll just go back up. Just remember that the main thing to remember here is that you start your analysis looking under multivariate tests for the time by group interaction. That's the first place you look. You found a significant interaction effect. Okay, that kind of affects the way we think about the time main effect, right? Because the time main effect is saying, yeah, there's a decrease in depression over time from pre-test to post-test to follow-up, but you can't really interpret it just like that because of this interaction effect. The interaction effect is telling you additional information. It's saying, sure, there's a reduction over time, but there's really a bigger reduction for one of those groups compared to the other group, and that's probably what you should pay attention to. Okay? So it's not just that these means are going down over time, it's that there was a different type of effect here at time 2 where the mean for the confidence building folks really dropped a lot, but not so much for the math skills. That's going to be the story that you're going to want to write up when you write up the results for this. Okay, so I think that's pretty much all you need to know for the mixed ANOVA. Why don't you go through and work on the WAWA to finish that up, okay?